All right, welcome everybody. This is TRiRODS for December of 2022. Today we have a talk from Martin Schobben. It's going to be about his work getting the first pure R package almost ready for release for iRODS. He's calling it iRODS, some great name. And he's going to tell us kind of how the planning went for this piece of software, as well as kind of the status of what he's got. He's going to show us a demo, and then maybe we'll talk about the future.
Yeah.
Take it away, Martin.
Yeah, thank you very much for the introduction. So I want to showcase a little bit of the work that I've been doing for the past couple of weeks. So trying to combine R and iRODS. And yeah, I guess it was maybe a bumpy road, ups and downs, but all in all, it was a fairly smooth process. So at the end of the talk, I will also hopefully show a little bit what I have been able to come up with and how that looks like. So what I considered maybe helpful to the audience was to give a little bit of introduction to R. So the programming platform. So when we talk about R, we talk about a declarative programming language, which is centered around functions and logic. Although I have to say, is it really? Well, not really in a technical sense. It's not all about pure functions. And certainly there are also many possibilities to include object-oriented programming in there. So actually it's maybe an intermediate between the imperative and the declarative paradigms. But what is maybe more interesting for iRODS in general and the iRODS users, it's a platform that is used basically for the statistics and also for the visualization of data, and so the data analysis part. And actually, the plot that I show here at the graphic at the bottom is also produced in R. Actually, in fact, the whole presentation is built up in R. And it's used by academia, researchers, but also a lot in industry nowadays. So when you think about the data science and the data analyst roles in these companies, they often request R as one of the skills that you bring along. What is also a very good match with iRODS is that it is an open source platform with a very active users community producing their own packages. So the process that I went through as well. So currently, this is a current estimate is 25,610 packages. So there's really a lot going on there. And to also give an idea of the popularity of R as specifically then a data science platform. This was a poll. It's already a little bit outdated, but I still think it gives a clear picture, is that it is popular. It's maybe still lagging a bit behind Python, but it's definitely also, it's running up after Python. So it's an important platform that is maybe also of interest to iRODS then for the exposure and for the integration. And I want to dwell a little bit more on that for, what are the reasons essentially that we want to use iRODS in combination with R. And I believe, or in my opinion, it's going to be a very useful tool, as R is often used as a way of creating reproducible workflows. So you get your data set and you transform it, and you put some descriptive statistics on it, and you plot the results. Often people put it in a scripted form, so they have these scripted analysis. And then you also have these quite ingenious tools such as the R Markdown, and also now a new package. I actually didn't check it out yet. It's Quarto, which is literate programming. So it's essentially like dynamic report generation. So using like code and actual text in one document. And you can, for instance, if you consider science, you can essentially create your own whole article just by using then your R platform. And to give an example, this talk, you can find it back in this repository, is also then created with R Markdown. And yeah, with this quote, that gives also an idea why we want to script our analysis. So then never again you come up with this question again, like what variable did I use and what type of statistics, because you can all find it back in this recipe that is the scripted analysis that you have safely put away. But then when you consider the data itself that you use for the analysis, we also have a couple of options there in R to use databases in the backend. So we have this columnar or tabular data relational databases like SQLite and PostgreSQL that can easily be connected with R through the DBI package and then with the ODBC drivers. But that still requires that you have to transform your data a little bit to fit the purpose of your analysis, and because you always start off with this tabular format. So then it sort of boils down to, can we not really work with the objects themselves? Can we not safely store that right away? And couldn't we use iRODS for that use case? So I try to sort of come up with a visual depiction of what I tried to say. So I would see it in this sense that we have now the opportunity already to make these reproducible workflows. So we have a recipe of how our analysis went and what steps we took, but we perhaps lack then this ability to also save away this data in the various steps that we have in our analysis. So we are lacking essentially the ingredients of this recipe, and maybe also the amounts of the ingredients to be used. So when we would be able to combine then iRODS with R, we essentially, well, we open up a sort of a black box in terms of that we can have more insight in the whole data lifecycle. So we can store the unprocessed data and all the various intermediate steps in between. Of course, the other benefits from iRODS, so we have the potential for sharing data, but then next to the sharing of the data, you can also pass along the scripts with your collaborators on your project. And when you think about that in a sense of an academic, like my background, an academic sense, when you are on a project and you want to present your results on a conference or want to put it in a paper, you can let also the editors and the reviewers trace back the origin of the data and all the imposed manipulations on that data. So really back to the source. In the end, then the ideal would be maybe to publish everything and then sort of like get into this blissful situation where we truly have open science and we can trace back everything. But of course, it would mean more data in the end. What I try to depict with this visualization is also more related to my background. So I envision the use case also in the sense that when you have a lab and you want to collect your data, that you have a sort of a central way of storing the data, and then you have your R workflows that can work on this data, could put it back, and you also have the potential of the online monitoring, what is going on essentially in the lab. So it's like feeding back into the lab. You could think about like graphical user interfaces, maybe. For R, that would mean like shiny dashboards, for instance, that could give you insight in what the essential flow of data in your lab is, and maybe also troubleshoot in sort of bottleneck situations in the lab where something goes wrong, and trace maybe also the origin of this situation back. But now let's go a little bit more into the details of the like the actual package that I've written so far, instead of only the use cases. So I'm going to talk a little bit about the design and the implementation. How did I really implement these ideas? But first of all, it's maybe good to give a brief history of what went on in this like interfacing of R with iRODS. So there was already for a long time an R package on GitHub that was built on the C++ API. For some time, I've also looked a little bit into that, and together also with Terrell, looked into the potential of like getting that like published on one of the like main repositories for R packages, but it seemed to be rather impossible to do that because the system requirements would be so stringent, and the ability to also distribute it to different flavors, so to Windows, to Mac, to Linux, was not really a solution, because you really had to build it on top of iRODS. So luckily with the REST API, we have now the situation that we can go truly distributed through curl then. And the progress already, I have a link included here, but I guess we can look at it later on as well. That contains now the current package, where the other one, the old package, is now archived. So when we consider some of the global design decisions that had to be made, then it boils down to those four major components. So what I try to do is to impose a functional style of writing the code. And in that sense, I mean that I try to sort of peel out chunks, like modular parts of the code, and make it like all like separate pieces of code, so that you don't get duplication, and better also unit testing of the separate functionalities. And also to try to peel out like the really pure functions and the ones with side effects. And already early on, the decision was made to essentially mimic most of the iCommands functions that we have, but not all of them. And I will go through some of them in some minutes. One other important decision was also that the R package is probably only going to be used by people that want to analyze the data. So it's not the administrators of the iRODS server that's going to be working with R. It's really the data analyst or the scientist that wants to use it. So the package is in a sense only made to be user facing. And a fourth component is that it is in a sense mostly usable in an interactive way. Although I think I made most functions in a way that it also works with like batch scripting. So you could use it for some automatization in the end, probably. The plot on the side is maybe not so really important. It just means to sort of show that R is true, well, in some part, a functional language, a functional programming language. So it's not only vectors going in and out, but you can also have the situations that you have functions going into the function to produce a vector, instead of using for loops, for instance. That it's hidden more in the lower language backend of R itself. So now I'm going to walk through some of the major components of the design that has been implemented so far. So for the authentication, I think it is best shown that it's like a split in two components. So we have the connection with the iRODS server. It's sort of a local, or it can a project or a user level file that is being created, just a text file essentially that hard codes then the host and also the zone of the server that you want to query. And then we have the so we don't have the init call, but we have the eout call. You can essentially also use it in the way that it is depicted here without any arguments, because it will make a dialog pop up, and there you can enter then your username and your password. So you don't have to actually hard code it within the script that you're making, but you can also do that as well. So you can also provide it as just strings. Yeah, I think that was those are the major components of this part. So for navigation, I think it's pretty straightforward. So it's similar to the I commands. So we can move back and forward with ICD. We can check where we are. We can check the content of the collections. Then for the objects and files that you want to put on the iRODS server, is again also just I put and I get. But now we can directly then work also with the R objects, so we can directly include those in the output and store them on the server. And I was actually up to some 2 hours ago fighting a little bit with that to get this also work for larger objects, and I think we got it now. And some design considerations that still have to be made is whether we're going to use actually expressions or strings as the variable that is going to be used as the argument. I'm not really sure how to go about with that. I'm actually now considering that it should be all the way through only strings and not the expressions, because then you get non-standard evaluation, and it can be kind of confusing actually, and it makes also the code harder to read. And then for data discovery, I think there are some quite there are some differences there. So I actually wrote it down wrong here, but so we have the iMeta, so that would be the same, but instead of iQuest, we have an iQuery. Apparently there is some discussion within iRODS as well as what is the correct name for that function. So we went for iQuery for R now. So yeah, I think these are the major components so far implemented. There's a bit more that I'm going to show in some minutes within the package so far. And then to the implementation, how does it actually work? How to use curl within R? Well, actually, I have to say there, it has been made easy there. It's sort of this mantra of standing on the shoulder of giants. So these are some of the high producers of packages within the R environment. And so we already have an R interface that wraps around libcurl, and also a wrapper again for that makes it even more easier to use. And also for JSON to be incorporated to be easily parsed within R. So you don't have to actually deal too much with that during package development. So my role was really to get sort of the logic in iRODS transposed on the R package and make that in a sort of a coherent way. Instead of all this application logic that I didn't have to really take care of. What was also important was how to actually develop a package like this, which is distributed. And then the testing as well, so the unit test. So luckily we have now the iRODS demo, so we can just with Docker Compose fire up a local host server. And so this is the way that I started developing this package. Later on, I also used one of the virtual machines on Utrecht University with the help from Christine. So that was really good to also see how it works on a remote server. But that was only in a later stage. What is important as well, that testing is done in a way that you initially, so the unit testing I'm talking about is that initially you really query or hit the API, but then you also generate mock snapshots. And this is really important because if we want to distribute this package throughout the CRAN or with the CRAN repository, and when we want to get it on the CRAN repository, we need to be able to get the test running without a connection to iRODS, without internet connection. So mocking is the way to do this. You essentially give some snapshots that reproduce then these R structures that would come out of the response of the API. It's sort of a trick, but it seems to work, and there is actually also a package that helped with that, so I didn't have to deal into detail with that as well. What is implemented as well now is that these snapshots are updated automatically with GitHub actions. So if there would be changes in the iRODS REST API in the future, then the snapshots will capture this whenever we commit something there. And maybe we can also do it in a time schedule basis that it updates these snapshots. And so this last step here, the RCMD checked, this is really the official CRAN checks that gets your package accepted or not. So this has, if we want to publish it, it has to go through this. And for that, we need this whole setup for testing that I've shown now in these steps here before. Maybe it's good to branch off now to a live demo session. Don't know if I get feedback now or that I should just do this.
That's fine. Are there any questions from anybody watching?
Because then I can branch off, or I can branch off now to the demo and then later on talk about maybe the future plans.
Yeah, that sounds good.
Well, so and then let's go to the R environment. Let me see where it is now. Maybe a little bit of explanation is needed here. Yeah, I guess your standard maybe EDI environment. So this is our studio where we have the R command line here in the lower left corner. We can build our scripts here. I think the best way to do this now is that I'm going to write in the script and run it from the script, and so we can also look back if there would be questions. I'm not going to show how to install the package. So for now, installing the package, well, it's actually the details are in the README of the repository, the GitHub repository. There is a tool in R that helps you install that also easily. I have it already installed here. Just let me start maybe a fresh R session. And then we can work from that. So it is already installed. So then the first thing you have to do is to call your package from the library. And as I told before, the authentication and the connecting with the server, we're going to do that now in 2 steps. So one would be the create iRODS call. I'm just going to copy and paste this part here from a script that I have on the side because it's a bit too much of typing. But so I have already an iRODS server running, like the demo running on my local host. And I also give then the path on the server. Oh, I should have remembered that. So I already had a file in this project. So this could be placed at the user level or the project level, so that you can always start easily working again in connection to the server, and you don't have to type that many times. So essentially, you normally don't have to write in this override this rule because you already have it saved in your project. What you do have to do every R session, at least in the sense that I think would be now the most sensible situation, is the authentication. And as I said before, you don't have to hard code it in your script. So I should actually show that. And there's one more thing that I didn't tell you, is that I already made with the administrator functions another user within the server. So if I just use now iRODS, it will just give me then the pop-up window, and my user is Bobby. It's actually the same as we have on the README. And then we can type our password here. I don't know why it pops up at the top here, which shouldn't matter that much. And I think that should be fine now. Let us check where we are, so we can also navigate. Let's have a look where we are. So I guess most people know this also from just the I commands. We can move around between the different levels and then check again. Yes, we moved a level down or up. And we can also use a listing here. See what we have. Oh, we get an error. Actually, that was expected. So I did that on purpose to show that it is really user facing, because I believe how iRODS is normally set up, you're not supposed to be able to query this if you are a user. So let us go back again to the Bobby folder. So we can just use the relative paths here and then use it again. And then we see, well, there is nothing there because we didn't put anything there. Didn't talk about this function yet, but it's also pretty straightforward. So we can create a folder there. We can then also move up to that level and check that we are right where we want it to be. Okay, so cool, that seems to work. But the more interesting part that's going to help us to link then these our workflows to iRODS is working with our objects. So let us make some fun objects here. And let's start really simple by making a vector of integers from 1 to 10. This would be your normal, the normal way that you do that. We can just print it like this to see that we actually got it. I hope it's clear that, so we have everything, the output here in the terminal then. So let us now try to put this object on the server. Then we just use iPut. Then we can check if it is there. Well, it seems to be there. This is actually a little bit different than the current master branch on iRODS on the organization repo. Before I had just the object without extension, and I think it's actually better to have the extension of an R object also included. I'm actually not entirely sure what RDS stands for, but I think it's our data structure, but I'm not sure. Didn't look it up. So it makes it more clear that we are dealing with an R object here. I think that would be more helpful, but yeah, it's maybe something for discussion afterwards. So to get it back, I'm still going to use a string now. I'm considering to make it also just an expression like an input, or maybe also make input to only take strings. I'm not sure what would be the best way yet. It has to do with this non-standard evaluation, whether you want it or not, and the readability of your code in the end. So I get on X gets the object back then. So we can also, if you want to, we could also store it in a different variable then. Something like that. R is also, as always, copy and write. So there's nothing like referencing like in the C or C++. Okay, so this is okay. This is a very simple situation of an R object, but now let's go to the more complex situations. And I got this only working just before, so I hope that it works now as well. And that would be, for instance, creating of plots, like the plot that I showed in the beginning of this talk. So let's make a plot. The call would be then ggplot, and I'm going to use this iRODS data set that is like standard incorporated within our base. And then we're gonna take a variable from that data set. Maybe it's not so important to really pay attention to the syntax here. And we're gonna make a bar plot out of that. And I'm not gonna show you actually the output, like the actual plot yet. So I'm just gonna store it as an object, because that's possible with ggplot. But right away store it with output into iRODS. Let's see if it works. This was tricky before, and we see that the performance is maybe not, there's some latency there, so it's maybe not ideal. And then get the object back again with iGet, and then see if we get a result now. And yes, we do indeed. So I think this is a pretty cool feature that you can, regardless of what kind of object we're dealing with, we can then put it into iRODS and retrieve it later on. So we could, if we have a scripted analysis, we could store away certain parts of it and retrieve it later on. What more? Yeah, more functionality that is perhaps interesting. There was some discussion on that already within the team of developers that helped me with this. Just gonna conjure up here a data frame. Don't mind my style here is maybe a bit sloppy in some places. Yeah. So we have a data frame, which if you print it on the console, it would look like this. But we want to enable people that don't use R to also work with it. So we want to save it as a CSV file. It is my opinion that this should be done within scripting with other packages rather than doing it within rirods. So we're just going to work with this object. I'm going to use this package now because I just find that very useful. Of course, we're going to write the CSV file, not read. So we take who the object and we give it a name. We can CSV out of that. So just to show you that we also have the file in my project here, you can see that full CSV is now. This is really a function where the side effect is stored within my project. And now I can take this file and store that in iRODS through R. So I'm just going to show you that it is there. You see the different objects. And we can also read it again. Oh, we have to read it, of course. Just put that I get. So full CSV. And you have to take care that it is already present, so we have to override it now. We have this built-in protection against that. So override is normally false, so we have to override it with true. And well, maybe not so very important, but then you could read it again with this external function that is not included, has nothing to do with rirods, and get it back into your workflow. And then the last bit is also the, well, I guess it's a core functionality of iRODS, which is very important, and I think it's going to bring quite some benefits also to the usage in R, is the inclusion of metadata for later data discovery, so you can find back these variables that you use within your analysis if you don't right away know what you're looking for, maybe. And it is implemented in this way that we have to use a list. Actually, in the back end of this, there's this implementation that the list is converted to JSON, but that is then simplified by the packages that I used. So the operation is adding the label. I'm going to add some attributes to it. The value. Oh. So if you now want to see if it is actually added to the file, we can use tools again and use then the metadata argument, and then we can see that who bus bar has been added. This is actually a data frame within a data frame. So if we want to store that, we could, for instance, look at it in a way like this. Yeah, so you see that this column is essentially then a list of data frames again, with then only for who we have these attributes. One more thing to show in the end. So we also have then the iQuery or the iQuest. And just copy paste here the example because I don't want to type this whole SQL query. So we can also use something like that to discover data. I'm not gonna go through all the cleaning up, but I'm gonna keep on working in the script a little bit more. But we can also clean everything up again. So remove the CSV file, for instance, check if it is gone. Yeah, I think this is what I have thought out as the demo so far. So if there are any questions or requests of what I can show, and it hopefully works and works not, I'm not sure, but maybe somebody has something that they want to see.
Hey, Martin, can you hear us?
I can hear you.
Yeah. So we've been talking amongst ourselves.
Really?
Yes, we have some thoughts. I noticed
Nice.
that your A and your V and your U came out in alphabetical order. Was that surprising to you? I mean, it seems like they went in correctly, but they You printed them out. It said foo, baz, bar, but then you did the next one.
Um,
Oh, I can't tell if you're going up or down.
this here, you mean?
Yeah, so you put bar in as the value second, but it came out third in that list.
Oh, that's right. Oh, that's. I thought I fixed that already. Well,
But
yeah, I
then,
think it's.
but then when you printed them out just after that, you see it says
Yeah.
attribute unit values. They're in the right place.
Yeah.
They're just coming out in a different order.
I think the nesting of data frames within the normal data frame is maybe not so well implemented in the printing methods on the console. I think it might be something like that because it is correctly entered, like you said already. So
Are you in charge of printing the order?
no, this is a base function. This is a base function.
That's surprising. Okay. Okay.
There are other options to maybe better print this. You can actually test this. What object did I store it in?
Okay. Yeah, it's just.
It was foo, right? Yeah. No, it was this XC. We could have a look how it looks like. Hopefully I have it here.
And then we have one other observation about your puts and your gets.
Right. Yeah, this doesn't help either because it just shows that you have data frames. Well, it gives you some more information of what the variables are actually. So the characters or the characters in the lists there. But please go on.
So I think, how would you phrase the one about the strings? So I think, when you did the data, was it write CSV or read CSV? It took two parameters. It took an R variable and then a string.
Yeah, these are not my functions, so this is just an external.
But that pattern I think might make more sense for put and get, because I was surprised when you said that it added the RDS, but you did not have to use the RDS to get it back again.
Yeah, so what my considerations there are is that within the R session is just a variable. If you want to store it on an external system, it is maybe helpful to show that this is an R object.
Right. So the idea would be that I put starts to look like write CSV. It has two variables instead of two parameters instead of one. And so you would have I put X, comma, and then the name that you would want to use on the remote system.
Yeah.
Then the I get would just be the name of the thing on the remote system, but then maybe it has an L value. So you save it back into a data object.
Yeah, but you can all, so saving it back would be essentially this. You just store it into a variable.
Yeah. And then you use p.rds rather than just p, but it would be a string.
Yeah, I think it actually works maybe even, I'm not sure.
Oh, if it does, then I would not be happy. That would be surprising. Does it work?
Yeah, that is the same.
Oh, okay. Don't want that.
Yeah, I don't know. So maybe I just removed the RDS within the system because I think it's more consistent to really talk about objects within the R, like in the R environment or the R session. But I thought it would be helpful for others that don't have R to know what the object is within iRODS then.
Was there anything else that we saw? Put the get. Oh, the column names for the iQuery.
Oh, right.
So when you did your iQuery, you asked for collection name and data name.
Yeah.
But then when they showed up in your output, it showed up as collection and data object. Does that mean that you have a magic conversion for all the possible things that jQuery can do into a column name?
I would have looked. I didn't look that much into detail into iQuery.
I guess my question is, how did it go? How did it go from data name to data object?
Yeah, I'm not sure.
Okay.
Maybe I hard coded that somewhere. I would have to look at this.
Because I think jQuery has the possibility of how many tokens does it have? Columns?
A few dozen.
80, 70 or 80.
Yes, yeah. So maybe that is not really implemented yet. So I see what you mean there.
Yeah, you probably don't want to convert them. You probably just want to leave them the way that they are.
Yeah. Maybe I did that. So maybe I did some like hard coded into the way it is shown now.
No, this is great. And you did you said the larger files is working. Did you show that one? Did I look away?
Yeah, well, the plot, for instance, that was an issue before.
Oh, that's right.
So I think that is.
Okay.
I was really happy about this point, like having your plot object stored there, and if you
Got it.
read it.
So that one was big enough that it did not work until we tweaked it.
Yeah, and I had something else that was, well, essentially, if you have just really big, well, we're just probably gonna overdo it now. Oh, that's not gonna work. I think that's big. Yeah, so the thing is that for the R objects, and why there is some latency now as well, is that I need to convert it to a file, an R object, so this RDS file on your local system before sending it over to iRODS. And I do also now the looping, although it is in the most efficient way within R, which is not ideal often.
Oh, to put the multiple parts.
Yeah, so R is not really good when it comes to, it's not like C++, like super fast.
So there's no threading necessarily in.
There is also options of threading, but the threading option is always tricky because if I want to implement it here, that means that it works on Linux and Mac, but it won't work on Windows.
Okay.
Yeah, this was an issue before. And let's stick it. Oh, that went fairly quick actually. Yeah, this is all working. I used the matrix before, that made it maybe more tricky.
Yeah. Does your stat call, your ILS, show the size in iRODS?
I had that actually in an example. Ooh, I think I overdid it here, maybe. Well, let's see. Now it's working.
Need a progress indicator.
Yeah, maybe, yeah.
I had a use case question, which may actually be more for you guys than for Martin, but we'll see. So I was thinking about the what is it, data to compute use case, and I think in our training we use PRC or the Python client to get the data and run some fake science and put it back, right?
That's right.
Would that be kind of useful? Would this be useful for something like that for the R?
We could definitely do this. We'd have to stand up the REST API.
Sure.
In the mix, but yeah.
But it wouldn't have to be on the really fast computer, right? Like it could sit over there, and then the R stuff is on the really fast computer. Okay.
Yeah, I think so.
Okay, I overdid it here.
Still
poor computer.
Still waiting. Okay.
Yeah, I had an example, and that is the. Oh, yeah, I have to terminate this here. That was an issue before, but it was working now.
Are there any other questions from the group who's connected? No pressure. Okay.
But the things that you noted now, are you going to put it in in some issues or so?
Oh, yeah. We'll write it down. I've got two.
Right.
Yeah, so
I
maybe,
think that's going to be useful discussion to get that right now.
yeah,
I'm in favor of having less arguments than more. That is my design opinion on that. So
that's right. I mean, I agree, but at the same time, we don't want it to be ambiguous. And so, putting
yeah,
that,
I see what you mean there. Yeah, that it's not expected results based on.
we have one question in the chat. Is it also possible to calculate checksums on the fly and have them checked upon up or download? And I think this means the checksum option. Have we implemented the checksum option?
Where would it be, in R or?
It would be in the
Rust.
It would be in the stream. Oh, how would it do that?
We have to.
Yeah, the answer is no. Not yet.
But I think that would also be interesting, yeah.
There
I
is
guess it would be
possibly you could implement an iChecksum R function, which would just hit. Have we implemented that in REST API either? All right, well, the answer to that one's no. Okay, so clearly these are both being built in parallel, so
Did you write that down?
we'll write that down. Right.
I mean, there are like rolling checksum calculations, right?
There are, but we don't have those implemented either.
Yeah, it's just like, that's a thing that maybe we look at
Mhm.
our future.
I think there's an old issue about CRCs.
Yeah.
All right, Martin, that's it. Go for it.
Yeah, last bit then. Yeah, well, essentially the future plans then. So for those listening, if you want to contribute to the package, I try to sort of make a coherent documentation of how that should be done, considering the dependencies that I'm using here and also some of the testing per request, and also how you can deal with safely storing your credentials during the development and not exposing them without yourself knowing it, maybe. So yeah, that's written down on the website. That is linked to the repository on the iRODS organization then. And so where to go from here? So as it is already, I try to check that the package coheres to the formatting for CRAN, so the official repository. As it stands now, I think it could go through, at least when I do the checks, the RCMD checks, it all works, and also on different flavors, so macOS and Linux and so forth. And we also have the GitHub Actions that does that automatically for us. That all looks good. And so, as I understood it now, TRiRODS, so official release is then aimed for the summer. And in my opinion, this package opens up also more possibilities later on. So one of the things that I'm considering is that you can build a package on top of this, the data manager, that is more from my experience working with students, that you can maybe impose a way, like sort of an opinionated package that sort of forces people to label their data and get a sort of a unified metadata schema for your team or for your working group. And the other package that is more to do with the integrated lab. Yeah, I'm not going to dwell too much into that, but I have also lumped some of these ideas in another website under the name of Fairy Labs, so to create the Open Science Lab. So yeah, many ideas, much to do still, but I think up to now progress is going quite well, and so the references to the packages used, and that's it actually.
That's it. Thank you. That's great. Are there any other questions before we call an end to this session? Anybody here?
You're gonna release from the stage.
Oh, a live stage release from UGM 2023. Maybe.
What does, I guess, stability look like as far as, with the REST API itself possibly undergoing changes? What does that mean for the iRODS library?
I think we have to communicate well.
Yeah.
Yeah.
We think that, so we've now had 4 or 5 applications get built against the REST API.
Mhm.
And I think it's coming together it's pretty close to its own 1.0, I think. Adding checksums or something would be additional, so that wouldn't be a change in the interface. But that's a use case we hadn't seen or heard about until just now, so that's
Yeah.
good.
Anyway, as I build it so far with this like modular setup, probably if you change something that has to do with how I should change the call, that is just a couple of lines of code. So
Yeah.
probably it's not that much of work. I think most work already has been done now.
Great.
A wonderful answer. All right, well, thank you again. I will thank you, and we will end this for now.
Right.